core basics of Python, important data structures and theory like linear algebra, probability, and statistics that are foundational in data science. And now we move into how we use these tools in the realm of data science and see some applications. One extremely common, almost unavoidable application in data science is text processing, or in other words, natural language processing. NLP refers to a collection of different ways for a computer to make sense out of its interactions with a human being through a natural language, and is all about trying to understand human written text, which could take the form of blogs, emails, tweets, other social media posts, and papers. NLP is a very messy, complex, but very rewarding sub-area. Therefore, we have some lectures devoted to it. In one lecture, we will walk through some of the basic common NLP operations on the text of some of the famous books like Alice in Wonderland. And in another lecture, we apply these concepts in full speed. What we learn in this lecture is how to attach numbers to semantic meaning of books. In other words, we can see how the book Pride and Prejudice is different from Alice in Wonderland in terms of numbers. A significant portion of data you're dealing with as a data scientist is unstructured. That is, they are text extracted not from a database, but from sources such as social media sites, text documents, pictures, and so on. Therefore, one of the biggest challenges of a data scientist is to sort through this unstructured data and pre-process it so that the data mining and analytics tools can take over to extract the ultimate knowledge they're seeking. In order to prepare text data for the actual analysis and put our data into a useful format, there are some necessary steps we need to make, which are known as the pre-processing steps. We'll walk through this quickly in this video, and you can learn more about them in the lecture. When the computer reads a text file, it has no idea what it's looking at. All it sees is a collection of characters. It doesn't know the difference between different words, not even space from a number or a letter. They're all the same. So the first thing we need to do is tokenize our text by slitting on white space or special characters. So you would take the sentence, for example, data science produces insights, and it would split into a list with 4 tokens, data and then science, and then produces, and lastly, insights. So now, instead of just seeing one long string of characters like it was seeing it before, now Python will see a list with 4 distinct tokens. But some of the words might be a little bit more important than other words. For instance, the words the, and, of, or appear very frequently, but don't really offer much information about the sentence itself. These are called stop words. We will remove these words to allow Python to really focus on the most important words in our sentence. Also, the process of stemming helps Python realize that words like learn, learned, and learning all have basically the same semantic meaning. You may not think this is a big deal, and in a small sample, it's really not. But when you all of a sudden have a million email messages that you're trying to filter out based on spam or not, and you have a total of 150,000 words, any words that you can remove to allow Python to focus on the most important words can really make a big difference. Okay, so now Python sees a list of tokens you care about and the keywords that we think are useful for building some kind of a model. So now we have to convert it to a format that an algorithm can actually ingest and use to build a model. This is a process called vectorizing. It's basically converting the text to a numeric representation of that text, where you're essentially counting the occurrence of each word in each text message using a matrix with one row per text messages and one column per word. So now that you have this numeric matrix, you can find the relationship between the words and the messages in order to make prediction whether the messages are spam or not.
NLP. Natural language processing, or NLP, refers to the branch of artificial intelligence that gives the machines the ability to read, understand, and derive meaning from human languages. NLP combines the field of linguistics and computer science to decipher language structure and guidelines and to make models which can comprehend, break down, and separate significant details from text and speech. Every day, humans interact with each other through public social media, transferring vast quantities of freely available data to each other. This data is extremely useful in understanding human behavior and customer habits. Data analysts and machine learning experts utilize this data to give machines the ability to mimic human linguistic behavior. This helps save millions in terms of manpower and time, as you don't need to always have a person present at the other end of a phone. NLP is also a lot more widespread than you may realize. You use it every day in seemingly normal and insignificant situations. Don't know how to correctly spell a word? Autocorrect has you covered. Need to see if your article or thesis will get flagged for copyright violations? That's okay. A plagiarism checker will search through the web and find any cases of published documents which may match your work line by line. While NLP seems really cool, yet a cutting-edge and complicated technology concept, it is actually pretty easy to learn. You start off with a document or an article. To make your algorithm understand what is going on in it, you need to process it into a form which is easily comprehensible by the machine. This is no different than making a child learn to read for the first time. You start off by performing segmentation, which is to break the entire document down into its constituent sentences. You can do this by segmenting the article along its punctuations, like full stops and commas. For the algorithm to understand these sentences, we get the words in a sentence and to explain them individually to our algorithm. So we break down our sentence into its constituent words and store them. This is called tokenizing, where each word is called a token. We can make the learning process faster by getting rid of non-essential words which do not add much meaning to our statement and are just there to make our statement sound more cohesive. These words, such as are, and, the, are called stop words. Now that we have the basic form of our document, we need to explain it to our machine. We first start off by explaining that some words like skipping, skips, skipped are the same word with added prefixes and suffixes. This is called stemming. We also identify the base words for different word tense, mood, gender, etc. This is called lemmatization, stemming from the base word lemma. Now we explain the concept of nouns, verbs, articles, and other parts of speech to the machine by adding these tags to our words. This is called part of speech tagging. Next, we introduce our machine to pop culture references and everyday names by flagging names of movies, important personalities or locations, etc., that may occur in the document. This is called named entity tagging. Once we have our base words and tags, we use a machine learning algorithm, like naive Bayes, to teach our model humans sentiment and speech. At the end of the day, most of the techniques used in NLP are simple grammar techniques that we have been taught in school. Here is a question for you. Which of these NLP techniques is used to obtain words from sentences? A. Stemming. B. Tokenization. C. Lemmatization. D. Segmentation. Give it a thought.